Hey everyone, and welcome back to video 5 in this series, and we're learning how to use Spark within Microsoft Fabric. And in the last video I looked at how to create a data frame kind of from raw data, and we explored the importance of schemas as well. And in this video we're going to be taking it a step further and making that a bit more useful, and we can be learning how to read and also write files into a Spark data frame. So as ever, all of the code that I'm going to be showing you today, as well as the dataset that we're going to start using, which is this one, property sales.csv, is available on the GitHub, and I'll leave a link to that in the description below. But this is what our data looks like. This is not big data. This is 3 rows. This data describes various sales of properties that have happened in these 3 cities. So there's only 3 properties that have been sold, but it helps us just to understand, okay, the mechanics of Spark and how it works without getting overloaded with big data just yet. And what I've done is I've set up a Lakehouse here, and there's nothing in my Lakehouse apart from in my files area. I've added this property sales.csv. So you can go to GitHub, you can download the data and just need to upload it into this files area of the Lakehouse. And to do that, you just need to go to the Lakehouse. This is my Lakehouse here, Spark September. And well, there's a variety of ways to do it, but you can click on these ellipses here for files, upload files. And there it is there. So if you go back into our notebook view, so I've started this notebook, which you can also find on the GitHub. And so we're going to start by reading in that CSV into a data frame, because the data frame is where everything happens in Spark, basically. We want to be getting data from files into a data frame so that we can do transformations, filtering, and all that cool stuff. And we're going to start with this basic declaration here. So we're giving our CSV path, which is files/property sales.csv, once you've uploaded the data there. And to read a CSV file into a Spark data frame, we need to call spark.read.csv. And Spark is the Spark session. If we hover over it there, we can see it's the entry point to programming Spark with the dataset and data frame API. And if you're using, or if you've used Spark in the past, you need to initialize this session. Within Fabric, it's already initialized for you, so you don't need to do anything. You just call spark.read.csv and it's available to us. And from here, we're going to pass in this, which is the path. So we're going to tell it, okay, read the CSV from this file path. And we're also going to tell it header equals true, because our CSV file does have headers. So if I just run this here, okay, so here I've just called at the end of this cell display df_CSV. So that is what we've saved our data frame as, the name of our data frame. So you can see here when we call display in Microsoft Fabric or in any IPython notebook, then we get this kind of interactive table, which is our data frame here. And we can have a look, and we can look at the structure of our data frame. And it looks about right. You know, it's got all our columns, it's got the headers correct. We can export it if you really want to do that. But what we can do is we can explore the data types by calling df_csv.datatypes. And you can see that there might be a bit of a problem here, because we've got sales price, which is a US dollar value. And currently it's reading in the data type, the D type, as a string. So if we want to be doing any sort of aggregate functions or calculations on that sale price, is not going to work because it's reading it in as a string. And this is just hammering home the importance of a schema. So another parameter that we can pass into read.csv, and this is what I was mentioning in the last video, is infer schema. So in my last video I mentioned that this isn't perhaps best practice. It's a bit lazy because it's forcing Spark to do the work for us. So it's going to go into each of these columns and have a look at the data that you've given it in this file. And now if we run it again, this data types, well, it can see that now the sale price is an integer. So that does make kind of sense. But sale price might not always be an integer. So in our kind of sample data that we've given it here, yes, it is an integer, but I'm no property expert, but I would guess that it is possible to not be an integer for a sale price, especially if you're maybe converting from other currencies, or you don't know how this is going to work. So rather than inferring the schema, you might want to explicitly define the schema and maybe define that sale price not as an integer but as a float instead. So that's a little bit about we've read our CSV, and now what I want to do is just to kind of build up that muscle memory of reading from files, and we can also write to files. So now that we have our df_CSV, what we're going to do is practice writing that out to a JSON file, because just as easily as we read it in from a file, we can also write it out. So this time we're going to be using the data frame itself as the base of our function. And so we're going to call df_CSV.write.json. So we're going to write this file, and the format is going to be a JSON file. And we need to pass in both the file path and the file name that we want to give it. So here I'm passing in files/JSON. I'm going to create a folder called JSON, and I'm going to put this JSON file in it. And we can pass in various modes as well when we're writing files from data frames. You can have overwrite, or append, or ignore, or error, I think is another one. Okay, so we're going to be using the mode of overwrite here. So if it already exists in this location, we're just going to overwrite it. Okay, so I've run this cell here. Now let's have a look in our files location. We'll just update this path, and we can see we have now got this, and we've got our property JSON here. So this is what our file looks like under the hood of Fabric. So we've saved it now as a JSON file, so that's good. So now what we're going to do, strengthen those muscles up again, and hopefully you're getting familiar with the syntax here, is now we're going to read that same file back into a data frame, and we're going to call it df_JSON. So again, we're doing spark.read, this time from a JSON file, not a CSV file, and we're going to just display the results. So again, it's working well. We've got our structure here. We've got these different columns, and just to practice a little bit more, we're going to be doing df_JSON.write to Parquet file. Okay, so that's worked. And I'm also going to save two files here. So I'm going to save two Parquet files. One is property sales, and one is property sales 2. Okay, so now let's have a look at what we've got here. We can go back into our Lakehouse Explorer and refresh this. Okay, so now we have a Parquet section, and we've got property sales.parquet and property sales 2.parquet. Happy days. Okay, what's the point in all of this? Well, we're trying to build up the muscle memory of writing to files and reading from files into and out of data frames. And if you go to the documentation, and I'll leave a link to this one in the description below, and you can see all the different file types that we can read from. I've shown you some of those, like JSON, CSV, and we also looked at Parquet as well. So this is a really good resource for you to learn a bit more about all the different options for reading from files. Okay, so now we have our Parquet, and just to prove that we can do this again, let's read our Parquet file from this one that we've just exported, and again, looks like that's working well. Okay, so we understand that. Let's go up a level, and typically we don't query an individual Parquet file. Normally we're going to be pointing at the folder that it lives in, and we're going to be wanting to create a data frame from all of the Parquet files or multiple Parquet files under that structure. So now we're going to learn how to read multiple files in the same folder into a data frame. So there's a few different ways that you can do this. Perhaps the most simple kind of looking way is to use this kind of wildcard operator on the file path. So here, the reason why I saved 2 of these files now here is that we want to combine those 2 Parquet files into one data frame. And you might want to do this because maybe this is January the 1st, 2023. You have a Parquet file for January the 2nd, 2023, or you have a Parquet file. Generally we save data in lots of different partitions or different files in these kind of big data projects. So it's a really common operation to kind of gobble up all of our Parquet files and put them into one data frame so that we can analyze them. Okay, so this has worked. We've got df.allParquet. And another little handy thing that we can use is exploring the metadata of the files, because we've seen that this cell has successfully run. But how do I know that the data in this data frame contains data from each of these two files? Well, the answer is, what I've done here is the same query. So we're doing spark.read, and you can use a backslash here to kind of go onto a new line within these cells just to make it a bit more readable. So you've got spark.read.parquet, and again, we're doing that kind of wildcard operator on the file path. So we're saying, get me all of the Parquet files in this folder. And then we're going to be doing .select. So .select is something we haven't looked at yet, but what this line is showing us is, okay, select everything that is in this data frame up to this point and add on another column. And this is a kind of special column name, underscore metadata, that Spark provides us. So let me just run this and we can see what this one looks like. Okay, so we've got all of our existing columns as we've seen before, but then at the end we've got this underscore metadata column, which is interesting. There we go. So now we can explore this metadata column in a bit more detail. We can see the modification date, the row index, the file size, the file name, and the file path, that this row where it originates. So that's a really good way of checking that, okay, we do actually have the data that we think we have. Okay, so that's it for this lesson. For further learning, there's lots of things to learn about reading from files, and I'll leave a link to the documentation here, again in the description for this video. And in your own time, you can look at more complicated scenarios, such as ignoring corrupt files, more elaborate filtering of that path using something called path glob filter, and also more techniques for dealing with recursion in kind of nested folder structures as well. That's it for this video. Remember, you can grab this code on GitHub. You can leave a comment below with any questions that you have about this video or any other videos in this series. Make sure you subscribed, like this video if you're feeling generous, and I'll see you in the next one.